our third example is going to be asking if given these two sets, if a function from a to b defined by this set of ordered pairs, would that be a function? Okay, so what do we need to check? We need to check that these three underlined things are true. So obviously this is going to be a subset because every element on the right is an element of our B and every element on the left of our ordered pairs is an element of A. So that's true, it's a subset of A cross B. Then we need to check that everything in A, every one of these elements maps onto something in our codomain, our B. And that's true. We have a 1 that maps onto something, a 2 that maps onto something, and a 3 that maps onto something, and a 4 here that clearly maps onto something. So we meet that second criteria. Now the last criteria is to make sure that everything only maps onto something once. So this means that 1 has to appear once, 2 has to appear once, 3 has to appear once, and 4 has to, 4 here appears twice. This means 4 is mapped onto two different things in our codomain, which means that this last condition is not going to be true. It is not true that every element here has exactly one element in the codomain, such that the ordered pair is an element of the function. So this is not a function. If you still can't see why this is, let's draw out the sets. Okay, so I've drawn out our two sets A and B. Now let's draw our function. So we're saying 1 goes to 2. 1 is mapped onto the element 2 from our domain to our codomain. So we draw an arrow from 1 all the way to 2. 2 is mapped onto 4, so we draw an arrow from 2 to 4. 3 is mapped onto 6. We draw an arrow from 3 to 6. 4 is mapped onto 8. And 4 is also mapped on to 2 here. So obviously it's a subset of the Cartesian product because none of these arrows leave any of our sets in question. Then, does everything in our A have an arrow coming from it? And the answer is true. There is no lonely element here. Every element here maps onto something. Lastly, every element maps onto something only once. Well, that just means, is there one arrow coming from every element? Well, there's one arrow coming from 1, one arrow coming from 2, one arrow coming from 3, but 4 has 2 arrows coming from it. 4 maps to 8 and 4 maps to 2. So it breaks this last rule that 4 does not have exactly one element in B that it maps to. So this makes it not a function.